Here we are for this webinar on using artificial intelligence in a logical process analysis. There are in fact three of us hosting this. I'm the CEO of Marris Consulting. I'll show up in a second. The guy who's going to do all the talking and who knows what he's talking about is Thorsteinn, who will present himself in a second. And there is also Lise and Natalia sitting in the background, sitting behind that logo there, that are going to collect the questions, the written questions and stuff. And we're aiming for about 40-45 minutes of presentation by Thorsteinn, followed by 15 to 20 minutes of questions and answers. As I say, I'm not going to be talking much, so I'll do this one very quickly. I met Bill Dettmer in 2012, and we've been inseparable ever since. We've been running what we now call retrospectively the Paris sessions. That's every summer in June, the 6-day course that was run teaching the LTP training to a number of people, which I participated in, so I ended up getting certified, of course, watching all this. And we've set up an online course, if you don't know it, on the logical thinking process course with Bill Dettmer, video recorded, so it's video on demand. And then you can either have just the course or with Thorsteinn some coaching, and so Thorsteinn does the coaching with Bill. Okay, I've been implementing theory of constraints for a very long time. I've done it more than 300 times all over the world, and I wrote a very boring book on a separate subject and in French, so you don't have to read it. Okay, so Thorsteinn is going to present all this, and I met him in fact during our Paris sessions in 2018, where he came to follow the 6-day course. And more recently, as I said, last year, we partnered up with him so that he can help Bill in the coaching sessions of the online course, right? And so over to you, Thorsteinn.
Thank you, Philip, and very happy to be here and with all those people. So basically, to continue with the presentation of myself, shortly after I attended the course with Bill, learning the logical thinking process, I published a book on it, From Symptoms to Causes, which is a 1-hour read, basically an introductory book, and I've been focusing quite a lot on working with the process ever since, and currently cooperating with Marris Consulting and cooperating with Bill Dettmer on this. And besides this, I've got a long experience in working with planning, budgeting, data analysis, and so on. And my education, I've got a BA in philosophy and an MBA from INSEAD. So that's enough about me. I think we'll just start with the webinar, with the presentation actually. So what we're going to go through today is basically the use of AI to help with qualitative analysis. And so I'll start talking about qualitative analysis a little bit and the difference between qualitative and quantitative analysis. I'll then discuss the large language models, which are basically what we're going to focus on today. I'll talk about the types of analysis that we're doing, especially the logical thinking process, the TOC thinking processes, and then how we can use AI to help us improve and speed up our analysis. Then we'll wrap up, and then we'll have some questions and answers at the end. So basically, what we're dealing with and what we have been dealing with and using AI to deal with until now, very much in management decisions, is to help with quantitative models, to understand trends, to discover correlations in data, and to remove bias from predictions that we're making. But this is obviously, it's limited. The quantitative models are limited because we rely on only explicit knowledge in quantitative analysis. And the fact is that most of the information that we use in decision making is actually tacit knowledge. It's knowledge that's inherent in our minds. It has to do with our experiences, relationships with people, and so on. a knowledge that's never finds its way into any database. And this is actually, until now, we have not been able to use artificial intelligence very much to help with those decisions. But the tacit knowledge is, many say it's more or less like 90% of all the knowledge that resides in our organizations. So we can actually use quantitative models only to deal with explicit knowledge, but qualitative reasoning we can use both for explicit knowledge and tacit knowledge. There are challenges, however, to qualitative reasoning, and I've listed some of those here. First, the decision-making process is usually very unstructured. It's not documented. We often omit validating the information that we use, the tacit information we use. And if we are using some more structured methods, they very often lack logical rigor. Then, when it comes to logically rigorous cause-effect analysis, it is very hard and it is time-consuming. And those who are familiar with like the logical thinking process and the TOC thinking processes will be aware of that. Our decisions are tainted very much by subconscious biases that we have. So the problem we have basically is this: we have to make decisions. We have to rely to a large extent on tacit knowledge, but we're not very good at making use of it. So what are the solutions? We can try to become more data-driven, but that will we can only do that to a certain extent because of those limitations I've discussed. Then we can try and improve our qualitative analysis. And in qualitative analysis, the logical rigor is the key, which means that it's difficult, it's time-consuming, and it's here actually that the large language models may be a game changer. So what are those large language models? It's basically, I think probably everybody will be familiar with things like ChatGPT by now, with I think about 100 million subscribers already all over the world. So those are neural networks. They're trained on a huge amount of data. And what they do is they sort of mimic human response to questions and commands. And those models are becoming better and better. And today they can actually perform complex tasks where they have to evaluate options and they have to make choices. Many people are worried about this, obviously, as with all new technology. And we're not going to talk about those worries so much, but it's today. But it makes sense perhaps to mention the main ones of them. That's the flood of uncontrollable propaganda and untruth that people worry about. Not being able to distinguish between whether we're communicating with a human or with an AI model. People are worried about job losses. And maybe the difference here with previous industrial revolutions, we could say, is that it's not only low-level but actually high-level jobs that may be lost. And then the threat from the artificial general intelligence, which is sort of the next step in this development, but it's not here yet. The main question here is actually how can we react? And there are three ways to react. We can panic and try to stop it, but that's not going to work. We can stick our heads in the sand and maybe we can say, yeah, well, no surprise, it's called artificial, ha ha. But that's not the right response, because even though those models aren't perfect, they're very powerful. Or we can face reality. We have this technology now, and we should really ask how can we take advantage of it for for our own advantage, basically. So the main strengths of those models when it comes to management, they can answer very credibly almost any question. Credibly doesn't mean that their answers are always true. We've seen that very often. They can write, they can summarize texts, they can analyze texts very quickly and very effectively, and they can evaluate and help us evaluate cause-effect statements. The qualitative analysis, just so we look at that again, the limitations of qualitative analysis, it's basically the final 2 points where those models can be of use for us. To reduce the time and effort needed for cause-effect analysis, and to minimize the impact of bias on our analysis. So, logical qualitative analysis, what I'm talking about here mainly is are the TOC tools, the logical thinking process, the TOC thinking processes. And basically, for those who are not familiar with this process, it's good to go through it very quickly. So the process itself, it starts by defining our goal and defining the requirements for reaching our goal, and then to look and see which of those requirements are not fulfilled. Then we look at those unfulfilled requirements, basically undesirable effects as we call them, and we look for the root causes behind their existence. Often a root cause can be explained by a conflict. There's a conflict underlying the root cause, and then we have to solve the conflict. Once we've done that, once we've eliminated the root causes and solved the conflicts, we start looking at the future and identifying how we're going to actually use the solutions we've come up with to reach our goal. And finally, often we have to go into the details and we have to meticulously outline precisely how we're going to get to that goal, basically. So the foundations behind the logical thinking process are, the main foundations are three. It's a structured approach. We use a specific tool for a specific situation and we work in a structured way. We use rigorous logic. Rigorous logic is really the key to valid conclusions. And to make this possible, we use visual analysis. A big current reality tree, for example, we wouldn't really be able to use it without the visual approach. But there are challenges using this, and that it requires, becoming good at it requires a lot of training, and it can be very time consuming. If we just look at a small example of a logical thinking process analysis, a very simple example. We have in the center, we have the goal tree, and we have our goal, which is to have a bigger and more profitable business. We then do a current reality tree of why we are not achieving all that is needed to get to the goal. And the root cause we identify in the end is we have a narrow and limited product line. In this case, the reason we have a narrow and limited product line is we have a conflict between what we should be doing. So we cannot decide if we should invest more or if we should not invest more. And this is what's preventing us from actually tackling this root cause. So we analyze this, we look at the assumptions behind the logical connections between the goal and the requirements and prerequisites. And we find a solution, which is to use the existing capacity we have to launch a new product line. So that way we don't have to go into a big investment. The solution is to go into new markets with a new product line, and that way to achieve a bigger and more profitable business. And some aspects of this process we need to map out more precisely. How precisely are we going to get the new product ready for distribution? So that's a very quick overview of the logical thinking process. So where does the AI come into the picture here? What we can use it to do is basically we can use it to speed up initial analysis, to give us a draft of a story or a business case or something very quickly, to summarize and to simplify complex cases. We can use it to scrutinize logical connections, to find missing premises from our analysis, to clarify statements, and to simplify logic trees. And what we gain by doing this is we can work faster, and I believe one of the main impediments that keep us from actually using the logical thinking process more is time, the time it takes. We get more robust logic trees, and when doing this analysis, logical validity is crucial, because if we do not stick to it, we may very well end up just with something that only confirms what we already believed instead of challenging what we actually already believed. And finally, and this is quite important, it helps us also, interacting with the models helps us to hone our own logic and language skills. So I'll go through four different examples now of using the model called ChatGPT 4 for this. And I'll start with a draft analysis. Basically here, I'm sort of getting a draft goal tree. So I ask the bot, basically the AI, a question, and my goal is to get a high-paying job in AI. So the question is, what are the 3 to 5 critical success factors that must be fulfilled to achieve this goal? And in a matter of seconds, I get an answer. I need education and skills, I need a specialization to build on, and I need networking and industry engagement. It's not bad for the start for a goal tree. Obviously, when we create a goal tree, it's our own personal situation, preferences, and everything comes into play. But this is not a bad start. So this is just an example of how we can use those models to speed us up, basically. The next example has to do with prompting, and the prompting is very important when we use those models. So now I'm just going to give you some examples of prompts that we can use, and what we get out of it, and what we learn from it actually. So now I have an if-then statement, basically. If I open the door of the cage, the bird will fly out. And my first question to the AI is if this is a logical statement. And the answer is it is. It is a logically valid statement, basically. And that's just the formal evaluation of the logic in the statement. Now, and you pay attention to this prompt quite carefully. Now I want to find out if the premise is enough to come to the conclusion. So I ask, is the premise sufficient to unavoidably lead to the conclusion? Premise, I open the door of the cage, conclusion, the bird flies out of the cage. And now I get a suspicious answer, basically. And when we read the answer, we see that the bot is not really grasping what it's talking about. It says, when the door of the cage is opened, it allows the bird to have the opportunity to fly out. and therefore it guarantees it will fly out. But this is not logical, and we get sometimes errors like this from the AI. So, and this is why it's so important that we prompt it correctly. So how do we prompt it in this case to make sure that we actually get a logical answer? What I try now is this: identify all the underlying premises for the following conclusion: the bird flies out of the cage. Assume that one of the premises is I open the door of the cage. And now it gives me the premises, all the premises, and even some relatively silly premises like that birds can fly and that the bird is inside the cage and that the door is closed, and so on. But by this we see basically how much it matters to prompt the bot correctly. Now the third example, leaps of logic, or what we call long arrows when we're doing logical thinking process analysis. Long arrow is basically that we are missing some intermediate steps between the premise and the conclusion, or we are missing some contributing causes. So now I ask you to evaluate the validity of a statement, and this is actually taken out of our teaching material as an example of a flawed statement. If I buy chocolate ice cream, my car won't start. And it points out that this is not logically valid, which is of course correct. The conclusion doesn't follow logically from the premise. But now I want to take it to a test. I want to see if it can actually make this statement make sense. And I get an interesting answer here. So I ask it for some potential intermediate steps or additional causes that might make this conclusion valid. And it comes up with, well, it's quite imaginative, I would say actually, that I get an allergic reaction from the ice cream, which incapacitates me, and so I can't start the car. And this is actually a bit creative, I would say, but this is basically an example of how we can use those bots actually to fill in. You know, this is a very silly example, but even so, it can make it turn it into something that might eventually make sense. Now, the final example I'm going to go through has to do with the current reality tree. And just to explain what the current reality tree is and what lies behind it. There are some assumptions behind it. The first is that what we usually call problems are not actually problems, but they are symptoms or undesirable effects of underlying root causes. And that to eliminate the symptom, we actually have to identify the systemic root cause and we have to remove it. Now those root causes are very often some hidden assumptions. And often it is enough just to articulate the assumption to figure out the solution. Now the current reality tree is a type of root cause analysis, and there are many available ways of doing root cause analysis, but what sets the current reality tree apart from most of those is how logically rigorous it has to be. And this logical rigor is actually the key, and it's the key to the whole of the logical thinking process and the TOC thinking processes, because it's what is needed we have to basically, when we do a root cause analysis like this, we have to challenge our own assumptions, our own biases, and this is what we do using logic. So we go through small steps, direct, unavoidable cause-effect relationships to come to a conclusion on the root cause. There are challenges, of course, to this approach. We often, even if we try to be as logical as possible, we may overlook some crucial but wrong assumptions, invalid logical connections. Sometimes our statements aren't clear enough. And what this means is basically that if we have just one error at the right place in the tree, it might invalidate the whole analysis. So how can we use AI to help us with that? Here I'm going to use an example. This is actually an example taken from my book, From Symptoms to Causes. And it's got to do with a hospital that's experiencing bad financial results. And we've analyzed the situation, and we end up by finding a root cause, which is a faulty KPI that we have, targeting salary per person per department. And this leads us to hiring less experienced people. We get a lot of mistakes, high failure rate, which means that customers leave us. And in the end, because we're hiring more people than we would have if we had experienced staff, and all the training and everything, we end up with a higher payroll cost, and we have a negative reinforcing loop here. What I'm focusing on here is basically the entities in yellow, and I want to ask the bot if this is valid. If we hire people with little experience and inexperienced people work slower, then we'll have to hire more people. So I basically ask it, and I start by asking it about the logical validity, and the answer is it is logically valid. It's formally valid. But I want to go deeper than that. I want to find out if there's something missing here, and this is something that I've used. I've used the AI a lot to actually do this, and it's very effective at it. So now I ask, if we hire inexperienced people and they work slower than experienced people, does it necessarily follow that we must hire more people? What other conditions must be fulfilled for this to be true? And notice that I specifically ask for other conditions, and this is in order to prompt the bot to think about that. And it gives me several conditions that might have to be fulfilled. And the one that flies in my face basically has to do with workload. It has to do with capacity. And this way, I've used the bot to draw my attention to a missing premise that it can actually be quite important here. And the missing premise is this, one in the red circle, that we do not have excess capacity. Because in order for this syllogism to hold true, if we had lots of excess capacity, it wouldn't really matter, would it? If we hire inexperienced people and if they work slower, it wouldn't necessarily mean that we'd have to hire more staff. So when we look at the tree then, and if we plug in this statement that we do not have excess capacity, a statement that is, perhaps it's valid, perhaps it's not valid, but we have to check. And now we check. And if we find out that it isn't valid, then it means that the reason we're hiring more people is not that we have to, it's because we believe we have to, because we don't realize that we actually have excess capacity. So this changes, basically, fundamentally changes the whole analysis, and we've actually identified a root cause here that is affecting the way we're doing things. So this is an example of how we can use the AI. Basically what we're doing here is we're using it to draw attention to something to a hidden premise, an unstated premise that's based on our own bias and we don't question. Now, the key point here, how can we use those models to assist with our logical analysis? Mainly in 4 ways. We can use them the way as I explained just now, to identify missing premises. We can use them to evaluate the logical connections that we make. We can use them to simplify statements and clarify statements, and we can use them to tighten cause-effect chains and get rid of long arrows. And the value we get out of this, we minimize the risk of some unconscious bias adversely affecting our analysis. We can speed up considerably the scrutiny of logic trees, and the scrutiny of logic trees is a key step in building a valid logic tree. We have to get somebody else to scrutinize it, and it isn't necessarily always easy to find somebody to help us do that, somebody who has knowledge of the methodology to help us do that, and preferably somebody who's not in our department, maybe not even in our organization. We can use it to speed up drafting of logic trees, whether it's something like a goal tree we want to produce, or even if it's a complex business situation where we have to quickly find suggestions for what might be wrong, and we can use them basically to help us improve our own clarity of thinking. And it's the interaction between the human and the bot that's very important here. But we have to keep in mind that those models are not perfect. They can make mistakes, even grave mistakes. They can misunderstand us, and they can even use concepts in the wrong way, as we saw before. Prompting them correctly is the key, and that's what really makes all the difference. And it's interesting, actually, and in fact, that the other day I was discussing this with my son, who is a philosophy and computer science student, and we were talking about the AI, and he said to me, the single thing that's going to make all the difference now is basically knowing how to correctly prompt the AI models. This is going to be what sets you apart if you're able to do that. It's going to be so important in more or less all lines of work in the future, and I think he's right. To use the models productively, we have to have knowledge of logic, and we have to know and understand the categories of legitimate reservation, which are the rules that we use when we're constructing the logic trees. And we must use a structured approach, of course, to get out of this what we want to get out of it. So the choices we have, many people are scared that we're going to basically just outsource the thinking to AI, and it is actually it is danger, and we see this. For example, now we have with GPT-4, we now have the ability to let it look for answers on the internet. So it's not limited only to the data to September 2021 that was fed into it. It can look up stuff on the internet also. It's a new plugin that we can use if we subscribe to it. And the difference between this and, for example, just Googling, is that Google gives us a list of sources. But if we ask GPT-4 a question, it just gives us one answer. And when we think about it, we see that this can be dangerous. When we can ask it questions like this, and we can even let it evaluate logical connections and so on, there is the danger that we outsource our thinking to the models, and we end up in a vicious cycle of basically losing control. But what we can do is to use the power of those models to actually improve our own thinking, to become better logical thinkers by interacting with them. And that way we enter a virtuous cycle where we're becoming better and better at thinking and expressing ourselves and understanding others. So what we need for this is we need a large language model, and what I use basically is GPT-4. There are also specialist models like the Blue Dolphin, which is aimed basically at the TOC community. It contains a vast amount of information on TOC, and it's developing fast. We need to know the rules of logic, and we need a structured approach, such as the logical thinking process or the TOC thinking processes. So this is basically, those are basically the main points that I have to make regarding this. I want to draw your attention to a training course that we are now developing, which is harnessing artificial intelligence to boost qualitative reasoning. And it's going to be a short course, a half-day course, self-paced online course, but with feedback on exercises and feedback to questions from participants. You will have to have some basic knowledge of the logical thinking process or the TOC thinking processes. Not necessarily be an expert, but you have to know a little bit about it, and that's not so hard to come by. And the objectives of this course are mainly three. Is to understand how the large language models can help with logical reasoning, and what are the strengths and the limitations. It's to understand how to correctly prompt the large language models, and there we will focus especially on the categories of legitimate reservation and how each of those affects the way that we should actually prompt the models. And then third, to gain some hands-on experience through exercises of using the models with all the 5 logical thinking process tools. So with that, I'll hand over to Philip again, and to talk a little bit about the other courses that we offer, and then handle the question and answers section.
Thank you, Thorsteinn. Well, the other course is something we started in the autumn of last year, in fact, which is that with Bill we've been doing the in-person training now for over 10 years, and in Paris and so forth. But we've now developed the same thing, or as much as we can, the same thing in the online video on demand version. So that's been available for now 6 months. And there are 2 versions. You can either just watch the videos, or there's access to the videos plus coaching by Bill Dettmer himself and Thorsteinn Siglaugsson. So if you're new to the logical thinking process, that's one way you can get help. And of course there are all the books, the big green book and all that stuff, which will help you get on your way to the logical thinking process. Okay, so let's go straight into the questions and answers. Now, so far we've already got over 30 questions, and with the 2 people, in fact, have asked basically the same question. So I'll do a concatenation of those 2 questions. It's all about AI and mistakes, right? So here's one of them, but there were two like this. The language models often make mistakes, and sometimes their answers look biased. How can we then rely on them for logical accuracy?
Good question, I think, because we all know examples of using those models to try and get answers to some practical factual questions, and we may get wildly wrong answers, and this is basically an issue that we have to keep in mind if we're using those models to get answers regarding some facts. There are 2 points really here that are important. That when we use the models for logical analysis, we're not typically asking them about facts. We're prompting them to give us a feedback on logical connections, or to find missing premises or something like that. So we're not just asking them to tell us, does God exist or something like that, And secondly, as I showed earlier, they can make logical errors also. And this means basically that we have to be very good at logical thinking ourselves. The models help us to speed up the analysis. They help us to point out areas where our own bias is troubling us. But they will not think for us. Basically, we have to think ourselves. But we can use them to help us to think more effectively. Does that answer the question?
Well, I'll see if they react on in the chat. Okay. The second question is, for which of the logical thinking process tools is AI support most appropriate or valuable? I guess we're talking about the different trees and the cloud and whatever.
Okay. Yeah. I think it's most valuable when we're doing a current reality tree or a future reality tree, and this is because those trees are usually, and especially the current reality tree, the most challenging to construct, and this is also where we have the biggest danger of making serious mistakes. For goal trees, it's not that important. It's not that valuable when it comes to the goal tree. It can obviously, like the case I showed, it can speed up the construction of goal tree. But when it comes to the rigor of the current reality tree, it's invaluable. It can also be quite valuable when we're looking out for assumptions behind the logical connections in clouds, but mostly in the current reality tree, I think, which is usually the most time-consuming and difficult of those tools.
Okay, thank you very much. I've got another one, which is in Bill Dettmer's logical thinking process. There is the notion of oxygen, the necessary condition. I'll just give you my version of that, what that is. It's the necessary condition that is so obvious that nobody mentions it, such as if you apply a match to a candle, you're expecting a flame, right? And that is only true if you have oxygen, right? So when using AI, what happens to these obvious necessary conditions? I mean, you just get flooded by oxygen, or does it forget it? I mean, how does it deal with that nuance, which is, stuff that's obvious to everybody, but maybe not to a computer?
Yeah, it's let me just go back to one of those slides here, just so we have it in front of us when I explain this. This one here, okay. So the premises it suggests: birds are capable of flying. The bird is inside the cage. The door of the cage is closed. all of those are basically premises that we wouldn't really put into a tree, you know, because they're so obvious. So we could look at them in a way as we look at oxygen. Then it matters a lot also how we prompt the model. So we can ask it to basically limit itself to the most important premises, for example, or we can ask it to list out all the potential premises. So we can sort of manage that also. But we may get flooded with oxygen. Yeah, that's absolutely true. Yeah. And this is also, again, you know, those models are not going to think for us. They can just help us thinking.
Okay, sorry, I'm being a little flooded through questions, but let me see the next one I've got here. Where was it? I've lost it. Lots of comments saying that they're using it in the same way as you, and they have similar experience. Is there, from Pankaj Vora, is there simple yet effective way of constructing thinking process trees without AI, but using our own structured thinking approach? If yes, any concept or ideas on that? You can take that, or I can take that. I was hesitating to recommend whether to go to books or videos or whatever. How to construct a tree.
Yeah. Okay. So basically, there are of course structured ways of especially when it comes to building current reality tree, step-by-step process that we use when we do it, and following that process, of course, it's the best way without any other tools. It's the best way to ensure, to the extent possible, that the analysis is valid. But even so, it takes time, of course, to do that. This is something that's explained basically in Bill Dettmer's book, how to go step by step through the process of building a current reality tree. But it takes time, and so I would say that the AI is additional. It's an additional tool that we can use to speed up and to improve, even if we use a structured approach to building the tree.
Okay, thank you very much. I've got another question here from Henry Camp. I'm writing a very important strategy and tactic tree right now. What links do I need to know? Where should he look next?
Where to look? Currently, you can of course look at my blog, The Edge of Reason. I've written a little bit about this there, but there isn't much available as of yet. What we have now is basically to try out the models and basically trial and error, and to see what we get. The reason we're developing a training course on this is to sort of meet this requirement a bit. So that's something that might be useful. But as of now, I don't really know of any specific links that we can use for this. This is also new, you know.
Thank you. And we have another one from Renee Gunderson. A great example with using AI to find the missing premise. Do you have any recommendations on how to approach checking a complete tree with AI? Would you start at the bottom and walk downwards, would you start at the top, I presume you meant, and walk downwards, or start at the bottom? At the bottom.
Okay, yeah, this is a good question, because when we construct the trees, we usually start at the top. We start with an undesirable effect. If we assume we're talking about a current reality tree, we start at the top with the undesirable effects, and then we look for the steps down. But when we read a current reality tree, we do it the other way around. And that's basically also what we do when we scrutinize the tree. And what we are actually doing when we're using the AI to help us with the tree, we're scrutinizing the tree. We're going through what we have set up, and scrutinizing the tree. That's what we use it for. But it is not. It does not preclude that we can also use it to help us to identify causes behind effects, or at least to suggest possible causes behind effects. And in that case, we would go from the top to bottom. So it depends on what it is we're doing. Are we building the tree and taking advantage of the AI to help us build the tree by suggesting causes, or are we scrutinizing the tree? For a whole tree, unfortunately, we don't have any solution yet that allows us to take a visual tree and plug it into the AI just as it is, and let it scrutinize it. This is something that would be really helpful if we had, but we cannot. We can with GPT-4, we can get, well, what they call a visual structure, but it isn't really visual. It just looks like some code out of an old IBM computer. So not very visual, but that's the closest it gets. So we have to take basically the statement one by one, and normally what we do is we use this, we use this when we're dealing with something that we actually want to get a second opinion on. That's when we use it. So and when we're stuck, we use it. So we're taking individual statements and using it to help us with those. As of yet, maybe in a couple of months or something, somebody will come up with a ingenious solution that allows us to take a visual tree and just plug it in directly. But we're not there yet.
Thank you, Thorsteinn. There are lots of questions pouring in. We've got 5 minutes left. I repeat, if we can't answer the questions within the webinar, we'll answer them by email. So don't hesitate to plug some more questions in. We've got lots of comments also. I'll just give you one. Lots of comments thanking us for the webinar. That's very kind. Thank you. One from Serafin Larsen that writes, I really like using ChatGPT for to 1, improve and simplify the logical connections in a cloud, and 2, surface assumptions behind those logical connections. It seems really good at surfacing assumptions. This is where I have found the most value for myself so far. Sounds like your experience is similar. Okay. Don't know if you want to confirm that or add to that. That's not really a question, but he's saying,
Yeah, it's a good comment. It's a very good point, because this is also my experience that it's good at. It's actually a bit. It has some creative thinking, This bot does. Yeah.
So another question here. How much time would an average LTP, logical thinking process practitioner, save by using AI to support him in his work? I mean, how many minutes per tree or whatever?
Yeah, this is a difficult question to answer, or at least we cannot give any single answer to it, because it all depends on the complexity of the tree and the situation and so on. But given that we can, something that, if I just take the example that I showed earlier, let me just try to get to that slide here actually. This one, where I'm identifying an issue behind that missing premise basically. What this would take normally would be to, I would have to take the tree, and I would have to ask somebody knowledgeable in the LTP to scrutinize the tree, somebody outside of my organization, and this would take time, of course. I think at least it would probably with the interaction and everything, it would take at least an hour. But when I use the AI, it gives me an answer in a couple of seconds. So that's sort of the difference when we have a case like this. But it's very different. It's very different. It's going to be very different. But I think the main thing is that we can now, using those bots, we don't really have to get somebody outside to always scrutinize everything we do, and that saves a huge amount of time actually.
Thank you very much. There's also a whole series of questions that are in fact from the lean thinking, lean way of looking at things. One of them is, for instance, can we use AI to help us with 5 why problem resolution and stuff like that? And another one from Ariane, that does something similar exist for Hoshin Kanri approach? And if yes, how can it be applied? I don't know if I never discussed Hoshin Kanri with you, Thorsteinn, so I don't know.
I think this is something that would be more appropriate for you to answer.
Yeah, okay. I didn't want to steal your answer. So basically, yes, and in exactly the same underlying way as Thorstein's been describing for the LTP process. After all, properly constructed Hoshin Kanri doesn't actually have in the same way the arrows and stuff, but it has to be constructed in a logical manner normally. So exactly the same advantages should emerge using this approach for Hoshin Kanri, no problem. Okay. And there's several talking about the scientific thinking and lean thinking and stuff, because obviously the logic here we're looking at and looking for is there in the theory of constraints, but also in the lean community. One maybe final question, since we're just running out of time. What would you recommend as a first step to get started using this AI in LTP? Would you start with a simple test case, a school case, or would you dive into a real world problem to, for instance, check the robustness of your goal tree with its necessary conditions? And if somebody here has been seduced by what you're doing, should they try a real world hairy problem, or should they just get started with some very simple, 1 + 1 = 2?
I think it depends basically. If you have a real world problem that you're having difficulty with solving, and you already know how to use the logical thinking process, and you're building an analysis of it, I wouldn't hesitate to try to use the AI for that. But you can also, of course, start with something more simple. That's also an option. So it depends. That's the answer, I think.
Okay. Well, I'm afraid time is up, and as I said, there's still lots of questions that we haven't answered. We will get back to you via email on those. Thank you for being here. Thank you for your time.
Thank you. Bye bye.